So this is going to take you through and give you some pointers to help with this homework. And the first question is, why do atoms have no charge? If you remember the core knowledge that protons have a +1 charge and electrons have a -1 charge, and the number of protons and electrons is always equal to each other in an atom. Ion is one of our keywords we have to remember. So remember ion, all that means is a charged particle. Ions can be positive or negative, but they have a charge. Cations, if you remember, the way we remember this is we say cats, I'm positive I love them. So cations are positive. So how do you form a positive ion? Positive ions are formed when a substance loses electrons, because electrons are negative. You have to lose electrons to become positive. And it's going to be the opposite here. Anions, again, until you remember it, we can write anions with a capital N. To remind me, this is negative. So these are negative ions. How do I get a negative ion? What this is going to do is it will gain electrons. What's meant by electrostatic attraction? So the term helps us a little bit here, because the electro is to do with charges. And these are charges static. If you've got a static caravan, it means it doesn't move. So these are charges that don't move, do not move. So these are charged ions that are not moving. And the attraction, what type of charges attract? Then it's going to be opposite charges. So if I've got a positive ion and a negative ion, they will attract. So what is meant by an electrostatic attraction? It is oppositely charged ions attract each other. That's what goes on. Okay, table here. We have to work out the number of protons, neutrons, electrons in either a atom or an ion. So I'm going to do lithium first, and as my example of a metal. So lithium, if you look it up on the periodic table, we need to know the mass and the atomic number. So it's 7 and 3. So remember, the atomic number is number of protons. So that's going to have 3 protons. Because, as we saw earlier, protons and electrons have to be the same in an atom, it will also have 3 electrons. And to work out the neutrons, you do 7, take away 3. So that's going to give me 4 neutrons. 3 electrons, how do you arrange them? Well, 2 goes into the first and 1 goes into the second. If that's then going to become an ion, just remember here that this is not stable. So what it's going to do is lose that 1 electron. And when it loses that electron, then the number of electrons will come to 2. So it's going to be 2. Protons and neutrons, they don't change, so they will be the same. Okay, and it's an ion because now it's only got 2 electrons compared to 3 positive protons, so it will have a positive charge. Let's try one of the negative ones. We'll do fluorine. So fluorine, look it up on the periodic table, is 19, 9, and then its F is the formula. So again, bottom number is protons, so it's got 9 protons, it's got 10 neutrons, and has to be the same number of electrons as protons, so it's got 9 protons. Then all we have to do is put the electron configuration together. So 9 is going to be 2, 7. Now in this case, 7 is not stable, but to that become stable at 8, we need to add an electron. So 1 electron is going to come in. So that means that will become 2, 8, which means it will have 10 electrons. It will still have 10 neutrons, and it still has 9 protons. Okay, working out formulas, really important skill. So make sure you are confident in doing this. So the first one here is magnesium. I can see from the list they've given to help that magnesium is 2+. So magnesium is a 2+, and a chloride ion is the anion Cl minus. So that's going to be Cl minus. And because it's 2 plus, it wants to make 2 bonds. Because it's minus 1, it wants to make 1 bond. We cross them over. Magnesium is going to end up with a number 1, and the chlorine, let's put chlorine in here a second. Chlorine is going to end up with a number 2. So there we go, MgCl2. Use the same method for all the others. Just be careful because some of these here have got ions that are elements that are in the transition metals, and therefore you can't tell what the charge is going to be. But because it's ion 2, that means this is going to be a 2 plus ion. So here we're talking 2 plus ion. And also be careful because if you have a carbonate, so carbonate is Cl3 2 minus. If a number 2 has to come across to that, remember we've got to use brackets to put the right number of ions together. Okay, copper chloride is soluble. What kind of substance is this? So hopefully you are core knowledge remembering that ionic compounds, they are soluble, and covalent substances are not very soluble. So I'm going to put here insoluble. They don't dissolve very well. Okay, so we've got anything that's going to be soluble. So the option is only going to match the ionic ones. So it tells us is an ionic compound. So this is an ionic compound, and it wants to know the most likely melting point. If you remember, if it's ionic, it has strong bonds. And if it has strong bonds, that means that it needs a lot of energy to break them, to make them melt. And therefore, you would expect it to have a high melting point. The formula for aluminium nitrate state the number of atoms. Simple rule here, if you remember, is the number outside the bracket multiplies whatever's inside the bracket by that number. So we times the N by 3, and then here we also times the O by 3 as well. And then we'll add in the aluminium. Most likely formula for aluminium nitride. So if you look it up on the periodic table and do your numbering of charges or bonds, you should see that aluminium is a 3 plus ion, and nitride is nitrogen becoming an anion, so it's N3 minus. Okay, I'm going to leave that there for you to think about how you work out a formula from that. But if you follow the normal method, you will be fine. Copper nitrate contains copper ions. Describe how copper ions become copper 2 ions. So here all we're trying to describe is how something with no charge becomes positive. And you become positive by losing electrons. And because it is 2 plus, have a think about how many electrons that must have lost. Number 13, ionic compounds have high melting points. Well, they have a high melting point. What does that tell me about this substance? It tells me that the bond must be strong. So there are strong bonds in there which need a lot of energy to break. Solid doesn't conduct. Let's have a look at why. So my solid ionic lattice, and that just means a pattern that repeats, looks like this. Okay, and in order for that to conduct, we should remember that charges have to be able to move. So what has charges in here? It's the ions. Are the ions able to move? They're held in bonds, so they're not able to move. When it's molten, why does that change it? Well, if you make it molten or dissolved, what you are doing is you are breaking all of the bonds that existed inside this formula. And if I break all those bonds, what can these now do? These can all now start to move and migrate. And if the ions can move, charges can move, then it will conduct electricity. So the key thing here is the ions are able to move as the bonds are broken. Okay. Good luck with the homework. We'll go through it in class once you have finished it.